of 2u, where u is x or theta or whatever angle is this. 2 sine of u cosine of u. It's really easy to prove where that comes from using the sum things that we did yesterday, so it's up to you if you want to write this down or not, but I think you should at least just pay attention here. The sine of 2u, isn't that just the same as saying sine of u plus u? That's the same as sine of 2u. So this formula comes from using the sum and difference identities. So the sum identity for sine of u plus u would be sine of u cosine of u plus cosine of u sine of u. So do you see why it's just 2 sine of u cosine of u? I thought that was kind of cool. I never really looked at it that way before until the Ivy Tech class made them derive that formula. And so that's where it comes from, so it's not some magical formula. But it's really nice, because we talked about earlier in this chapter, you cannot separate that 2 from that u. So if you have something that you were trying to solve, it's harder to do that. So being able to rewrite it is helpful. I gave tangent next, so we're going to skip tangent and just go cosine next. So the first part, before I show you the first one, let's derive it. Cosine of 2u would be like the cosine of u plus u. Right? So the formula from yesterday would give you cosine of u times cosine of u minus sine of u times sine of u. And what would cosine times cosine be? Cosine squared minus sine squared, and so that's really the basic one of the value. But then books always give you 3 formulas for cosine of 2u, and that's because if you substitute in 1 minus sine squared for cosine squared, and you could substitute in 1 minus cosine squared for sine squared, which means you could write this all in terms of sine squared or all in terms of cosine squared, and we'll talk about when we solve equations why that might be helpful. So that's where these other 2 come from. They're the same thing, they're just using the Pythagorean identity. So this one is because if you replace sine squared with 1 minus cosine squared, you would get cosine squared minus 1 minus cosine squared. So the negative and a negative would make that a 2 cosine squared, and then you'd have a minus 1. So that's just using the Pythagorean identity. And then the same thing to get 1 minus 2 sine squared just comes from replacing cosine squared with 1 minus sine squared, and you end up with 1 minus 2 sine squared. If you had to memorize these, which you don't, but if you did have to memorize them, I would just memorize the top one, because you could always get the other ones from that. But again, that's just why they give you 3. And then this is where, for tangent of 2u, you shouldn't have to memorize it at all, because tangent comes from sine over cosine. So if we took, or maybe not. We could do that, but it's a lot more work to prove it. If we took this divided by this, none of it would work out, so obviously we won't work with that. But I can tell you what I did on the test. I was doing my entropy at home very late on Tuesday night so that I could grade their tests and give them back to them Wednesday. I didn't remember this formula, and so I really just took this over this, and I simplified it, and I got the same answer as if I would have done this, because cosine of 2u is the same as saying sine of 2u over cosine of 2u. And so I forgot that formula, and actually a few people on my class did the same thing. They didn't remember the formula, but they remembered the sine of 2u. You don't have to stress about that, because I'm not making you memorize it, but it's just something. What we're going to do, we focus on different things in the Math 137 class focuses on with this. We're going to focus on actually solving equations with this, kind of like what we did on 5-1, day 2, and day 3. So let's look at a couple. So here's 2 out. You factor a 2 out of this, but you can't factor the 2 out of this. So that's where the formula is nice to know that I can replace sine of 2x with that formula that says that sine of 2x equals 2 times cosine x. And again, you don't memorize that, you just have to know. This looks just like something I could have given you in 5.1 where I said solve this equation. And remember, I gave you some tips. Get it equal to 0, look for factoring, do not divide by a trig function. So the same thing's going to apply here. Even though it looks really like a good idea to divide by sign, it's not a good idea to divide by sign. So I'm going to subtract that over. And then say factor. Yes. So getting it equal to 0 and trying to factor is a really, really good step to take if you're solving the equation. So we have to kind of make sure our brains are okay with going from verifying identity before we're not allowed to do things over back to just solving the equation. So we're just making small things too. So now I'm actually going to factor out a 2 and a 5. And I'd be left with cosine x minus 1. And remember the good old zero product property. Two things multiplied equals 0, then I can break it apart that equals 0. So I can say sine of x equals 0, or I can say cosine x minus 1 equals 0. So I can say, I just divide by the 2 there, right? So cosine x equals 0, so it would be cosine of x equals 1. Remember, if it said find all solutions, you'd have to find the solution and then put the like plus 2 pi in. But this just says between 0 and 2 pi. So we should be able to do this without a calculator and tell me where does sine equal 0, where does cosine equal 1. Sine is y, so where does y equal 0? At 0, pi. But not 2 pi because it's not included. But you're right. Where does cosine equal 1? Cosine? Cosine equals 1 at pi. It's just a 0, right? Cosine is x. So it should just be 0, but we already have 0 here. 0, 0 again, it's not wrong. So it's pretty good. So that whole part of still having to know your trig values, still having to know. What about number 2? Number 2 is where I think it's nice to know that there's 3 options, because you should pick the option that creates the least amount of work for you. It's not wrong to start with the factor, but think about your 3 options here for what cosine of 2x can equal. It can equal cosine squared minus sine squared. It can equal 2 cosine squared minus 1. Or it can equal 1 minus 2 sine squared. If you got to pick, knowing that on the other side there's a sine over here, which one would you pick? The first, the second, or the third? I would pick the third one too. Why, Emily? Yeah, there's just a sign in it. And remember, if we can keep it all in terms of one trig function, like that's a good way to go. And so that's why they give you 3 options on that, just because you want to pick the one that makes the most sense. So I'm going to start by replacing this with 1 minus 2 sine squared x. And this one's not like number 1 in that we're not going to have the GCF because this 1 is here. But what we do have is a constant, a squared trig function, and a not squared trig function, which you want to recognize that as that's like a trinomial, right? That's like the U substitution, if you like U substitution. So I'm going to still get one side equal to 0, but I'm going to move this stuff over here because I like to keep my sine squared positive. So I'm going to write that as 0 equals 2 sine squared x plus sine of x plus 1 minus 1. I'm going to show you something just because I want you not to ever do this, and people do it all the time, and it makes me want to scream. Some people do this. they move this over and they write 1 equals 2 sine squared x plus sine. Because they realize that the 1's going to screw up their GCF, right? And then they pull a sign out and they say 1 equals sine of x times 2 sine of x plus 1. See where I'm going with this? And then they say, oh, well then sine of x equals 1, or 2 sine of x minus 1 equals 1. You see yourself ever maybe doing that? I had kids in calculus do this before. It makes me crazy. Because just because two things multiply together to give you 1, does it mean one of them equals 1? No, right? 1 times 3 times 1/3 equals 1, but that doesn't mean one of them equals 1. And so that's why the zero product property is called the zero product property, because it only works with 0. And so I just want to show you that, just to try to say never do that. You can never break two things up to equal any number but 0. And so this is very wrong math to do. But it happens a lot. And so be aware of that. It only works with 0. It was very, very special. Are you guys use substitution people? I'm not a use substitution person. I don't like to. You're factor by grouping people. Have I showed you the non-factor by grouping way of factoring? Did I show you the non-factor by grouping way, or it's too big? It kills me sometimes that we factor by grouping on a problem like this because we get so easy to figure out factor by grouping, but that's how you're taught to figure out otherwise. I'll go back to it, but I'm going to do it anyway for people that maybe want to see it. Because this is a prime number, I don't know, do we all want a prime number? To me, it's really easy to just make your parentheses and fill your answer here, but you got to think a lot about this. What are the only things I could write in here for that would multiply together to give me 2 sine squared x? 2 is a prime number. What are the only two numbers that multiply to give you 2? 1 and 2, right? So one of these has to be 2 sine of x, and one of these has to be sine of x. That's the only way in the f of FOIL that I would get that. Do you agree with me on that? The f of FOIL. And this is the L of FOIL, and it ends in a 1. What's the only two numbers I'm going to write here that's going to multiply to give me 1 there? 1 and 1. You follow me on that? So this works really well when you have prime numbers. Like there's a 3 there, there's a 1 here, or a 3 and a 2. So there's only one option really, it's just getting in the right spot. Which means instead of having to do all the factor by grouping, you could just fill it in, and then your job is to make sure you get your signs right so that you can get a plus 1 in the middle. So think about this is the OI of FOIL, right? We got the F, we got the L, we got the OI. The OI tells us how to put our signs. So this would be 2 times 1. I would need that to be positive and subtract the 1 times 9. Whoa. This is how I was taught to factor everything, whether it was prime numbers or it was something like 48 when there's 8 million possibilities. This is really like the guess and check method to factor. I'm not saying you have to ever do the guess and check method. I just feel sometimes when you are in precalculus, that you should at least be aware that you don't have to factor by grouping every time. If we factor by grouping, you get the same answer, I promise. You rewrite this as 2 sine of x minus sine of x. And then when you factor that out, you're going to factor out a 2 sine of x. And over here, you're going to factor out a negative 1. And this is what you're going to be left with. And I promise it always works. But that's how I was taught to factor, so when I see prime numbers, it kind of kills me that I have to factor by grouping every time. So I like to at least show you that. No one ever likes it. Everyone always thinks like it's very crazy, but I just think you should be aware of it. Someday you can like this hard. Just think about it. We make it better. Here's the prime number. What's the one together? 3. 3x and x, right? That's, yeah, it doesn't have to be, but it's much harder. Much harder if this was a 12, because what are you going to do? Are you going to do 1 and 12? You're going to do 2 and 6, you're going to do 3 and 4, right? With me? So you can do it. I had to do it with every problem I ever factored. That's how I was taught, is I had to write all my factors down and just think of the possibilities. That's the way I was taught to do it. I didn't learn factor by grouping until I was in like my teaching classes. My professor that was teaching me how to teach math taught me that, and I was like, this is the dumbest thing ever. Why would we just get to check is what I thought, because that's how I was always taught to do it. But then my first year teaching, I taught me to check, which was in my textbook, and I couldn't begin also. I went over to my notes for my class, and I taught them factor by grouping without the textbooks, but it was kind of like, when I went to school, that's I wasn't taught that one. So that's why I think if it's a prime number, I think it's worthwhile to be aware of this method, because it's usually quicker. Like, what multiplies and give me 1? 1 and 1. So that part's the easy part when they're prime numbers. The hard part is you have to think about what you do to get the oi of FOIL. You do the outside and you do the inside, right? And that's what we do to get those two numbers and we factor by grouping. So in this case, if I did the outside, I would have 3x. And if I did the inside, I would have 1x. And that's what you would do if you did factor by grouping on this. When you do the guess and check method, you kind of just do it in your head and you say, okay, what do my signs need to be so I can get a minus 4x in there? Well, I need a minus 3x and a minus 1x. So, and you can check that you get a plus. I mean, again, not required that you have to do this. I just think it's worthwhile to kind of be aware that that's an option, especially on a problem that has a lot of steps in it. I showed you. But I promise it's not wrong to factor by grouping. So on this one, I had 2 times 1 gives me positive 2, and negative 1 times sign gave me negative 1, so that's how I knew that was right. But I know it's not comfortable, so it's okay. Okay, back to this. Now if I set this equal to 0, I get sine of x equals 1/2, and sine of x equals negative 1. Are you with me on that part? And now again, we did the algebra part. Now your job is to know the trig part. What angle or angles have the sine of 1/2? And I hope that we're feeling pretty good about this. On the retest, everyone that took the retest got a better score, but there's still, like on the no calculator part, there's still mistakes going on in the unit circle part of sine is y, and I know that the x starts with 1/2. So that tells me right away that sine equals 1/2 at pi 6. And you got to know that sine is positive in quadrant 2 as well. So that would be 5 pi 6. And where does sine equal negative 1? Three pi halves. And yes, you have to give me 3 pi halves. Because you have to be between 0 and 2 pi. So making it pi half is not acceptable because it is 0 and 2 pi. So, I'm going to show you a way to do this that you don't need a formula. Just because I think it's responsible. Well, as a math, when you leave the calculus and you go on to higher math, are you ever going to have a question that has a problem with an angle with a number in front of it and you want to solve it? Yes, that's the right more option. So I want to show you how to solve this without the formula, and then I'll show you the formula. So I can't separate this cosine 2x, but what I can do is I can divide this over, and that would say cosine of 2x equals. With me on that? It's inside the cosine. Like all you can do is use the formula that I use, right? Or not. Because what if it said cosine of 5x? You have a formula for cosine of 5x? No, but this label would work for cosine of anything x. So that's all. Okay? So notice, normally when I solve a problem, I did write x equals 1. Normally when I say sine of x equals 1/2, I say x equals, and we solve that, right? We can do the same thing on this, I can't separate this 2x right now, but I can say that cosine of whatever this is equals 1/2. So I can just think about this whole thing and say, well, 2x equals, so forget about the 2x for a minute, kind of, and just tell me the cosine, where does the cosine equal 1/2? At what angles do we know that cosine equals 1/2? At pi thirds. Cosine is x, and cosine is also positive down here. At pi thirds. So whatever's here, I can't really break it up right now, but what I can do is just solve for what's over here. And then think about if I wanted to solve for x, what do you think I would do now if I wanted to get x by itself? I can divide by 2, which means I can divide all of these by 2. Dividing by 2 is the same as multiplying by 1/2. Let's multiply each of those by 1/2. And 1/3, or pi thirds times 1/2 is just pi 6. And that's just going to be 5 pi 6. You can check that it works. If you plug pi 6 in there, 2 times pi 6 is pi thirds. So pi thirds is 1/2. But here's the tricky part of this. There's still more answers. Because we want answers between 0 and 2 pi. And up here, if I went the next one, I would be past 2 pi. When you cut it in half, 5 pi 6 is not close to 2 pi. Agree with me on that? So you have to think of all the answers until you get answers down here that would be more than 2 pi. So that means you have to think a little bit more about if this is pi thirds and this is 5 pi thirds, and I went back around, what would that next one be? What would be pi thirds plus 2 pi? 7 pi thirds. So that would be back up here, but adding 2 pi to it. Normally, we wouldn't give an answer of 7 pi thirds because that's too big. But when I cut it in half, 7 pi 6 is not too big. How am I going from here to here? That would be right. Think about if we listed every answer. If I said tell me all solutions, don't you agree we can just keep adding 2 pi over and over again? So I'm just going around. This was 2 pi, so I'm just going around. Because we have to give all answers between 0 and 2 pi. So although 7 pi thirds is bigger than 2 pi, the actual answer to the problem would be 7 pi 6. And then what would be the next one if I went 2 pi more around to 5 pi thirds again? 5. So it's the 7 pi thirds, 8 pi thirds, 9 pi thirds, 10 pi thirds, 11 pi thirds. Maybe it's easier when you speak the correct pi thirds. And if I take half of that, what do I get? And then I know to stop because 12 pi 6 is 2 pi, so I know the next one's too big. You're going to know to stop because it's not a coincidence. Normally we get 2 answers, yes? When I put a 2 in front of this, I get 4 answers. It's not a coincidence that it's double the answers. Guess what? If it said cosine of 4x, guess how many answers you would get? 8, because it's always 2 times whatever that number is. On my Math 137 test that those kids just took, there was a question that said cosine of 5x, which means they had 10 answers that they had to give going around that circle. And so there's no formula of how to do that for cosine of 5x. Like, you have to just know to solve it and then divide by 5. And so that's why I think that you should know how to do this. The good thing is, if it's a 2x, you don't have to do this. You could do it the way that we did before. So just to show you, if you think that you would never do it this way, to me this way's faster. But you could substitute in here any of those problems, any of those 3 things I gave you. I'm going to just do the cosine one, which was 2 cosine squared x minus 1. And then you could just solve that equation. It's a lot of algebra. You could divide by 2 first, or you can distribute. I distributed. So I'm going to say 4 cosine squared x minus 2. Then I'm going to add 2 over and get 3. Then I'm going to divide by 4 And then I'm going to take the square root. And I'm going to get the cosine of x equals plus or minus the square root of 3. And the square root of 4 is just 2. And guess what? So we get 4 answers. 5, 6, 5, 5, 6, 7, 5, 6, 6, 5, 6. And so you can do that when there's a 2 in front of it. But you couldn't do that if there was a 3 or a 4 in front of it. We don't know how to solve that. But there's some on your homework that you can do this way, or you can do this way. I don't care as long as you get the right answer. I just how to solve that. In calculus, we see questions like this sometimes, and not one person in my calculus class has any memory of what this formula is, but they remember that we can just find their answers and divide them. So that's why I think it's worthwhile to be aware of that. Okay, I got one more step on this. Formulas and expressions too, and I was on there because pretty much use what's the next day but what I am giving you is a power reducing one, which means you can take something with a power on it and get rid of the power. So sine squared is the same as saying 1 minus cosine of 2u all divided by 2. I'll tell you that my Math 137 books solve this for sine, so they say this equals plus or minus the square root of that, and you have to figure out whether you use a positive or a negative root. And the cosine squared of an angle is equal to 1 plus the cosine of 2u. The tangent squared on this is it's exactly the sine squared 1 over the cosine squared 1, which means like the 2 just cancel out. And the tangent squared is just 1 minus cosine of 2u over 1 plus cosine of 2u. And they really don't show up that often, but there's a couple in your homework that you can chat. Again, what is good about these things is it's really just all about recognition. But these are not long proofs, it's just recognizing how to write them, but more than anything. The hard part is keeping it straight, even though I let you have it. I'll have these printed for you on your test or on a piece of paper. When you see this, you have to think about what kind of formula should I be using? Should I be using the double angle formulas? Should I be using the sum and difference formulas, which you have to know? Or should I be using these power reducing formulas? And so you might see the squared one here, and you might think, well, maybe I should use the cosine squared, but there's no fraction over here, right? And so I think this goes back to the cosine of 2u that we did on the first page. And if you look back there on the cosine of 2u, one of the ways we could write that was just 2 cosine u minus 1. You can recognize that there's really not much to write here, except for thinking about how to make one side equal to the other. If you pick to work with this side, like I feel like you just this is exactly what that says. So you just have to recognize what u is. I'm going to work with this side just so I can show you this. If this said 6x and I wanted to write that as cosine of 2u, what would my u be in this? And what would I put right here? It would be 3x, because 3x times 2 gives me 6x. So if you can figure out which one to use, it's really just plugging it directly in, right? So it's just changing it, it's just the answer now. 2 cosine squared 3x minus 1 equals 2 cosine squared 3x minus 1. So I don't want you to think that there always should be that concept to an identity proof. Sometimes with these ones at the end of the chapter, it's more about so a lot of your homework today is like our beginning problems, where you're solving equations, and you have to think about integrity, factoring, getting equal to 0, and solving for it. And then there's a few problems like this. So 6 through 27 multiple to 3, and then 40. We are not going to have a test before spring break, but we're going to be really close to it. Start qualifying next week. Maybe I don't know. But it's not. hide it. I'll try to secret my back.